Here, we will continue analyzing the same dataset we have been working with in the previous videos. In this video, we will focus on understanding salaries from different perspectives using Pandas. Let's jump straight into the first example and see how it works in practice. In this example, we group the data by the gender column and calculate the average salary for each group. This allows us to compare how salaries differ between genders in our dataset. Let's run the code and see what happens. As output, we get a mean salary value for each gender category, which gives us a quick, high-level comparison. Now that we understand the basic idea of grouping and averaging, let's move on to the next example. In example 2, we are still calculating the average salary by gender, but this time we also sort the results in descending order. This helps us immediately see which gender group has the higher average salary at the top. Let's run it and observe the result. The output shows the same mean values as before, but now they are ordered from highest to lowest, making the comparison much clearer. With that in mind, let's continue to the next example. In example 3, we go one step further by calculating multiple statistics at once. Instead of only the mean, we now get the mean, minimum, and maximum salary for each gender group. Let's execute the code and check the result. The output is a small summary table where each row represents a gender and each column shows a different statistic. This gives us a much deeper understanding of salary distribution within each group. Now that we've seen grouped statistics, let's switch our focus to individual salary values. In example 4, we use n-largest to find the top 5 highest salaries in the dataset. This is useful when we want to quickly identify the highest earners. Let's run the code and see the output. As expected, the output displays the 5 rows with the largest salary values along with their associated information. Next, let's look at the opposite case. In example 5, we use n-smallest to find the bottom 5 lowest salaries. This helps us understand the lower end of the salary range. Let's run it and see what happens. The output shows the 5 lowest salary values in the dataset, giving us insight into the minimum earning levels. Now let's move on to creating new information from existing data. In example 6, we create a new column called salary level. Using the apply function and a lambda expression, we label each salary as high if it is greater than 6,500 and low otherwise. Let's run the code and check the result. In the output, we can see the original salary values alongside their new salary level labels. This kind of transformation is very useful for categorizing continuous data. Let's continue with one final example. In example 7, we first calculate the overall average salary of the entire dataset. Then we create a new column called above average that checks whether each individual salary is higher than this overall mean. Let's run the code and see the output. The result shows each salary together with a Boolean value, true if the salary is above average and false if it is not. This makes it very easy to identify which records are performing above the general level. That's it for this video. In the next video, we will continue our data analysis journey and explore the dataset even further.